Hello, this is Mr. Lloyd and I'm going through a section 2 of an ISA. So we're going through the temperature and rate of reactions ISA from 2015. So question 1. Do your results support the hypothesis? You should use a pattern and you should include examples. Now this question has come up on all past ISAs that I've seen. So it's pretty common. So what do you have to do to get the answer correct? You have to say whether or not it supports the hypothesis. So you just have to use your data and say, does it support it? So that whether that's correct or not is based on your data. For 2 marks, you have to either include a pattern or some results. And for 3 marks, you have to include both a pattern and some results. So a pattern, so for example, with the temperature and rates, the pattern could be something like, as temperature increases, rate increases. So a pattern is saying, as the independent variable does this, the dependent variable does that. Examples are something from your results, and that you've got to include at least 2, because then you can highlight the pattern. So for example, the example given here, when the temperature was 26 degrees, the time was 95 seconds, but at 47 degrees, the time was 24 seconds. So as you can see, as the temperature went up, the time went down. And if the time goes down, that increases the rate. So the best ones to just highlight the pattern would be the lowest independent variable value and the highest, because then that gives you the most extreme result. Right, so question 1b. So here's question 1b. What was the independent variable in the investigation? What was the range? Was this a suitable range and why? So you can have a go at it yourself if you want. Right, well obviously this will change based on what your ISA is actually about, but in this case it's temperature. So you need to say what the independent variable is. It's temperature. It's the thing you were changing in the ISA. Then you've got to give the range. So the range is the lowest value to the highest value. So you pick the lowest value of your temperature and the highest value of your temperature or any independent variable. And then you've got to explain whether it supports it or not. So, and also you need to make sure you include the units. So when you are giving the independent variable, say the temperature, so the units for the temperature. So in this case, for temperature, you go, it is 10 degrees Celsius to 100 degrees Celsius, for example. Okay, if you don't use the units, you won't get the mark for the independent variable. Okay, so what do you need to explain? Well, you need to explain, does your range give a pattern for your results? So can you see from your range that the time taken is decreasing or the rate is increasing? If you can, that is a suitable pattern. That is a suitable range. Okay, so does the range enable you to see a pattern in your results? So if, for example, you did 10.5 degrees Celsius and then 10.6 degrees Celsius, there probably wouldn't be a difference in the time it takes for the reaction because the temperature change is so small. That would be a bad range. Okay, so a more suitable range would be something like 20 to 70. Okay, because rate doubles at approximately every 10 degrees Celsius. So you should be able to see a good pattern there. Right, question 1c. How can you use repeated readings to get more accurate results? So, you go here. You should say a mean should be calculated. The word average is okay. You should say how you calculate the mean by adding the results together and dividing by the number of values. And then, for the 3rd mark, you need to say either you get rid of anomalous results before calculating, or a graph is plotted and a best fit line is drawn ignoring anomalous points. So this is quite straightforward, but there's something I'd like to highlight here, that sometimes a lot of people miss this mark that I've highlighted about how you calculate the mean, even if they know it, because they think it's too obvious. So you can't be too obvious in ISAs and in science exams in general. Okay, so if you have to say you have to do a calculation, it doesn't hurt to say how you do the calculation, because in this case and in possible future cases, saying how is actually worth a mark. Right, Question 1D. Most investigations contain errors and uncertainties. What is the largest error? How would you reduce the size of this error? So you'll have to think about yours. But in the case of temperature and rates, so this is the sodium thiosulfate reaction. This is talking about when the cross disappeared. So this is talking about you've got two colourless liquids, sodium thiosulfate and acid, hydrochloric acid, and they react, and one of the products is solid sulfur, which is a precipitate. And if you do the reaction by adding the liquids together whilst the conical flask is on a cross, then you will see the cross disappear because the sulfur will get in the way. So I'm just loading up so you can have a nice little look at what it does, what the picture is. So it's basically that. So you put, ignore what does there, you can do it with lots of other things, but in this case we're using sodium thiosulfate and acid. Well, there you go. They're both colourless. Eventually you'll get this solid appearing and you can't see the cross anymore. So that's a source of error. So that's one. How do you reduce it? So you need to say how you reduce it. So in this case you use the same cross. And then why does that reduce it? Because in the case of having the same cross, the size of the cross or the width of the lines is always the same. So 1 mark for identifying the error, 1 mark of saying how you reduce the error, and 1 mark for saying why that will reduce the error. So you need to think about errors in your ISA. This is a possible question. This might not come up. Right, question 1E. How could results from the other method that you research help you decide whether the investigation is reproducible? So sometimes you're asked to investigate two investigations. So you need to say something like, what does reproducibility mean? Well, that means if somebody else took your investigation and did it, could they get similar results to you? So could they follow your instructions and get similar results to you? Then it is reproducible. Okay, so if you say something like that, so someone else can do my practical and get similar results, that's a mark. Then you need to say, you need to compare to see whether there is a similar trend or pattern. And then you need to say, if there is a similar trend, it's reproducible. And if there isn't, it's not reproducible. So there you go. Quite straightforward. Question 2A, sketch graph. Yes, there is, in every past ISA there has been a sketch graph based on case study 1. So you will get some case studies, such as here. Here is case study 1, temperature of acid, time. So it's always good to look on case studies for patterns. So as the acid temperature goes up, the time goes down. So what do you get the marks for in the graph? Well, you get 1 mark for labelling both axes with the variables. And in this case, for some reason, you don't have to give the units. So you would get a mark if you put temperature of acid on the x-axis and time for magnesium to completely react in seconds, that would be a mark on the y-axis. Except you can draw the axes either way around, okay, as long as the curve's right. Then an appropriate line is drawn. So it should be a concave curve from top left to bottom right. So it should go like that. So obviously there's no set way of doing this, but you need to be looking at the results and thinking about the shape of the line. But there's always an automatic 1 mark by just labelling the axes, by just copying what is written in these headings and putting them on the axes here. Right, question 2B. The higher the temperature, the shorter time it will take to react. Look at case studies 1, 2 and 3. In all past ISAs, there's been a question where you look at case studies 1, 2 and 3 and say, do they support a hypothesis? So, well, I'll show you what they're for. Sorry. The first mark is for getting 2 case studies out of the 3 correct about whether they support it or not. The second mark is for getting all three correct and doing an explanation for one, and the third mark is for getting all three correct and doing an explanation for both, for two of them, usually 2 and 3. So a couple of things to think about here. The first thing you need to decide is whether all the case studies are correct or not, because if you don't get that right, you won't get more than 1 mark. So you need to look at the case studies, are they correct or not? Then you start adding things in. So case study 1. So as the temperature of the acid increases, the time decreases. That is correct. Case study 2. So as the temperature of the acid increases, the mean time decreases. That is correct. Case study 3. Oh, case study 3 is a bit funny. It's got temperature, so you can do it, but it's also changed concentration. But let's just look at one concentration. So at 0.2 moles per decimeter cubed, as the temperature increases, the time decreases. 0.4, same thing, same thing, same thing, same thing. So for all concentrations, as the temperature increases, the time decreases. So that is correct as well. So the explanations. So the things they're looking for, the higher the temperature, the shorter time the magnesium to react, but it's not linear. So you think about the relationship. A linear means if you were to draw a graph, that would be a straight line. Case study 2, increasing the temperature by 10 degrees seems to halve the time taken, which is something that is written in the chemistry textbook. And so you need to look for patterns. And then case study 3 is if it involves an additional independent variable, you need to look at each additional independent variable and say, is it true? And in this case, it is. So for example, the independent variable that you're looking for is temperature, but you've also got concentration. Does it change with each concentration in the way that you expect? Yes. The time goes down when the temperature increases for each concentration. So you've got to say that. Right. Case study 4, they're always hard. So to keep costs low, you have to have your oven at 150 degrees and leave the car inside the oven for 2 hours. So the hard thing about case study 4 is there's so many factors. You've got different paint, temperature, time for the paint to dry, and cost. So, but they've given you a starting point. They said for 2 hours and 150 degrees Celsius is the best way, is the cheapest way for the paint to dry. So 2 hours and 150 degrees for that gives that point there. These lines are for different paints saying when they dry. Paint A will not be dry after 2 hours and 150 minutes. And that gives you a mark. Okay? But then you need to give a sort of statement about every paint. So if you're doing a case study 4 question and there's multiple things, have a look at all of them. So case study B does dry after 2 hours 150 degrees. Paint C also does. Looking at this, paint C dries a lot quicker. You could dry paint C, if you were using it, in 2 hours at 100 degrees or 3 and a bit hours at 50 degrees. Okay, so 2 hours at 100 degrees would save you £50. That would be £100 for 100 degrees, or 150 for £150 for 150 degrees for 2 hours. Okay, so that's why paint B, so sports, paint C is the most expensive, blah blah blah. But it might be cheaper, because then you've got to think about paint costs. So then you've got to compare two costs. So paint C is more expensive, but then you save money on drying. So that's something you need to think about. And then there is a final mark for saying there is no indication of the volume of paint, which means you can't exactly calculate it. So for example, if it took 1 litre to paint a car, if you use paint C instead of paint B, your paint will be £1 more expensive, but you'll be saving £50 on the drying, so that's okay. If it took 100 litres to paint a car, that costs £700 now, and that costs £600. So that's an extra £100. So you won't be making a saving on using Page C. So that's something you need to think about. They're always difficult because there's multiple factors. And then the last two questions have been the same in all past ISAs. Context, so you need to think context, for example, temperature. So you need to say, to get a detailed explanation, you need to say why this experiment is relevant. And then you'd say what the company would do with this experiment. So a detailed one, a company that produces adhesives could determine the setting time for the adhesive at a range of temperatures so customers would know how quickly it would work. So there's the context bit for the customers knowing how quickly it would work. How would the company use it? They do an experiment at different temperatures, and then who would use it? A company that makes adhesives. And then the last one is a 4-mark question. Draw your graph. You get 1 mark for labeling the x-axis with units, 1 mark for the y-axis with units, doesn't matter which way around they are, 1 mark for plotting your results correctly, and then 1 mark for either drawing a line of best fit if it is supposed to be a line graph, or labeling your bars correctly if it's a bar graph. If your independent variable is continuous, i.e. numbers, you should be doing a line. If it is categoric, i.e. names like red, green, blue, it's a bar chart. So that should be quite straightforward. So there we go. That's just a quick go through paper 2, paper 2. So I hope you have a good time. Bye-bye.